This is the first ever installment of Under the Hood, a Heliux speaker series where we bring on our customers and major stakeholders to talk about their stories and how it fits into the broader goal of Heliux. We're really excited to have you guys here today, and with that being said, I'll pass it off to Alex.
Awesome. Thank you. First timer here on a fireside chat, so bear with me. So first and foremost, thank you to Shinola for allowing us to host at this beautiful venue. I'm from Metro Detroit, and I remember when this brand was getting started back in the 2010s, I want to say. And they just, represented the city and the comeback in an incredible way. And so deep admiration for the brand. Thank you to all the employees here, Marion especially. They are open for business, by the way. So after the fireside chat, please go buy some watches, bracelets, notebooks, the whole 9 yards. So thank you. So welcome, Christian.
Thanks for having me. I'm really honored.
Yeah. Thanks for coming up from Orange County. Christian is our guest this evening. He is the head of integrated systems at Mach Industries. Mach is developing next generation autonomous defense systems based out of Huntington Beach, California. So Christian had a long journey up. We spent the day together. It's been a great day. And let's go ahead and dive in. So
yeah, flying out might get a little interesting tomorrow, so we'll see.
Yeah, hopefully you get home, right? I want to start with modern manufacturing, right? I think everyone here knows, what manufacturing is, but perhaps what they don't understand or know much about is behind the scenes or under the hood, perhaps. Describe to us what a manufacturing company really does and how does it operate. And when I walk into a factory, am I walking into a grungy, dark place, or is it a beautiful place like a Tesla factory? Can you maybe paint us a picture here?
To me, when you boil down to the fundamentals, a modern manufacturer should really focus on one crucial aspect. It's delivering product to the customer. And to me, modern manufacturing is really the method in how you deliver that product to the customer. And manufacturing itself, I don't think stops when the product goes line off. It includes everything from design, development, production, test, delivery.
Whole enchilada.
Whole 9 yards, yeah.
Love it. And you spent time at some seriously impressive, I would say, manufacturing institutions, right? Toyota literally wrote the book on production systems that is taught in schools today. I remember reading that for one of my supply chain courses when I was in college not too long ago. And Tesla, has done the near impossible by breaking into automotive in the early 2000s, and now look what they're doing. What did you learn from, say, the wise professor that is Toyota relative to the young, ambitious, energetic student that is Tesla?
Yeah, that's a good question. Both companies are really dominating the space in which they're in. I think both of them take a vastly different approach into how they execute in the space. Luckily for me, I immediately leaving college, my first job was with Toyota. And they have a long legacy in establishing the Toyota production system and what good manufacturing looks like, right? They did it in an age where they didn't have the software tools to leverage against their capacity. So they took a different approach into controlling the highest piece of variability there is in manufacturing, which is the human side of things, right? Toyota took a really good approach. They're founded on really good core pillars: respect for people, continuous improvement, right? And in this establishment of control, they essentially focused their philosophy around process standardization. These are things that I think are much more efficient today due to software tooling that we have now available to us. But Toyota did this in a time when we didn't have that. So they really, when you enter a company like Toyota, in my case, when you enter as an engineer, you get to your desk and you have a big binder like a 4-inch binder of all the people who had done this before you and what they did to be successful. And if you stray away from that, it really isn't possible. You're there to help be a part of the system and build the machine or sustain the machine, right? At Tesla, it was much different. They really took, in order to control the human aspects of things, they took, in my opinion, 2 really key distinct approaches. One was designing hardware around their software and really optimizing their product to be manufacturable. And the other one was building really robust internal software systems. And
Interesting.
yeah, interesting. That's something that just wasn't available at Toyota. And at Tesla, it really allowed the engineer to focus all of their time around value additive work. When I was at Toyota, a lot of the time was spent paper processing, ensuring you had the proper routing, signatures, sign-offs, building a binder full of proper documentation to get to the next step in a process, right? At Tesla, it was much different. The product was directly integrated with the operational software that ran the system. So as soon as you executed something, you were able to go to the next step without any interference.
Probably get fired from Tesla if you made a binder with a bunch of instructions. So.
I'd imagine so. Yeah. It wouldn't be a good look to have that on your desk.
All right, so you're bringing up software, and I happened to stalk your LinkedIn profile last night. Your summary states, and I quote, 3-letter acronyms give me war flashbacks. For those in the audience who don't really understand what the 3-letter acronyms are, could you maybe define what those mean for everyone in the audience?
Yeah, so when I refer to 3-letter...
And be objective here. Save the feelings for after.
Yeah. For sure. When I refer to 3-letter acronyms, I refer to the traditional business systems that tend to be siloed throughout a company. But these business systems dictate how you run operations and how your company executes as a whole. Typically, in manufacturing, you'll hear acronyms like PLM, ERP, MES, WMS. The list goes on and on. But each one of these things are usually siloed applications that you use to execute across a product life cycle. And if we bring it back to the beginning, like what is manufacturing? It's the method in which you deliver a product to the customer. So traditional business systems typically, in my opinion, don't make sense when you have 7, 8, 9, 10 different applications to achieve your very holistically simple goal.
Okay, tell us how you really feel.
Yeah, they make me want to bash my head through a wall. A lot of these systems were developed in the 90s. They get exacerbated and forced onto companies due to things like cost plus, time and materials contracts, especially in aerospace and defense, where as a startup, you want to secure as much revenue as you can as fast as possible. But in doing this, you tend to get yourself into situations where you might handcuff yourself in the method in which you operate. I think there is a wave right now. I think that is changing, especially with the People's Republic of China and how hardcore they're going with their ability to manufacture, especially products that can really have an adverse effect on the infrastructure of modern AI development, right? TSMC, Taiwan, semiconductors.
What do you wish to see if this ecosystem is fundamentally broken, we'll call it? How do you see us moving past that?
One, I think regulations need to change in terms of how product is delivered to critical customers like the government. Two, in that regulation shift, companies need to be a lot more streamlined with how they execute across what they're doing. At the end of the day, you're trying to deliver the product that you had conceptualized to your customer. This shouldn't be an avalanche of things that need to happen. And if there are companies that can come in and make that executional flow as streamlined as possible, that should be rallied around.
There are a lot of companies. So you're spending your time at a Toyota, at a Tesla, and more recently you've shifted over to earlier stage. So Shield AI, now Mach Industries. What are the key ingredients at this stage to building a successful manufacturing company at scale? What are you doing today that scales with you to tomorrow?
What we're doing today, and I really think startups like Mach, for instance, need to be the source of the new wave of how we conduct ourselves as a country, essentially, in order to fight off these threats that I mentioned a second ago. And in doing that, it's simple as saying, I refuse to fall into the old legacy ways of the past, right? Knowing that a system that causes cognitive drag across your entire operational scope, knowing that that's there and choosing to go into that avenue so you can secure revenue, so you can execute on a contract. I think companies are now becoming more wise to that, and they are really going above and beyond in terms of developing robust internal systems, making really good partnerships with people trying to change the narrative and trying to change things, how things are done, essentially, in the space.
And there's like an unprecedented amount of capital pouring into the space in the early stage. What mistakes are you seeing earlier stage companies? What mistakes are they making in regards to their enterprise systems? Are they implementing too early, too late? The right systems, the wrong systems?
So there's really two things I could really touch on here. One, as a startup, it's very hard to get yourself to dedicate valuable time and resources that you could spend on engineering development and improving that iteration cycle of your product, getting it to a robust state, and choosing to take that capital and invest it towards operational systems, right? It's not a direct impact on your product. But regardless, it's critical infrastructure. You're going to need that to execute and scale. So a big thing that I see with startups is a lot of them, by no fault of their own, they lack the foresight in seeing how critical these systems are when they move to make that next step. You hear this age-old tale, right? What kills startups more than anything? Trying to scale too fast. Why can't they scale too fast? They can't execute across their operations. They either don't have the funding or they can't execute. And a critical pillar of that is the systems you have that you execute through. So I think there is a lack of importance that's placed around that, I think, for a lot of startups. And another thing, when you do have these systems in place, it's kind of what I alluded to early, chasing that revenue and getting yourself into a situation where you unknowingly force yourself down a path of reliance on third-party systems that were built in the 1990s, right?
So one thing that I picked up on, and I would say, from an incentive perspective, we're incentivized to sell our software to early stage companies, but often I do recommend not buying our software when they're so early for the very reason you described. It sometimes is too burdensome to implement a software system. The extra overhead that does come with it, it adds a little bit of drag sometimes, especially early, to engineering development. So when is the right time? Like you clearly described that it's important to scale with, but when is the right time? Is it by funding stage? Is it Series A, Series B? Is it more a maturity level of the product that you're developing? Is it based on customer demand and the revenue that they're chasing? Is there a playbook, or is everyone slightly different and it's kind of dependent on what you're building?
I really think it's a generally agnostic of all those things. I think it's the moment you realize that you're going to make the transition from a concept to a manufacturable product, that's the moment you should really look into scaling your systems.
So we're in San Francisco. I have to ask, where does AI come into all of this? AI, automation, machine learning, whatever you want to call it. But there's a lot of impressive technology being built right now and being used in many other industries.
Lots of .ai companies now.
For the record, we are not a .ai company. Yeah, but we do own the domain.
Yeah, specifically in manufacturing, I mean, there is so much opportunity that is to be had with AI. And it's easy to go overboard and say, how can AI remove jobs that we have in manufacturing operations, right? I think AI is best used with humans in the loop. But regardless of that, there are some interesting opportunities in the semiconductor space, in the traditional manufacturing space, AI that can write machine code for you, things that can help you as an engineer. Say you were a product designer, right? If you had a system that could help you determine if your product that you were designing can be executed at a high scale, regardless of where it is in that system chain, is a huge benefit. And if it can do that, it could also assist you in your day-to-day operations. And we're going to get back on cognitive drag caused by legacy systems, but anything that can help alleviate that workload is going to be a huge benefit.
Sure. I think a common misunderstanding about this space too is everyone complains about the software itself, but I want to take a step back from the software and talk about implementation. And you talk about war stories, war flashbacks. I sure as hell have PTSD from some ERP implementations back in my day. Do you have any fun horror stories to share with us?
Oh boy. In terms of implementation, this one's more of an optimization, right? I won't name where I was working. I won't name the companies I was working with.
Fair.
But a traditional ERP is not easy to work out of. It takes multiple button clicks, multiple windows, multiple steps to execute something as simple as accepting parts coming into a building, right? Well, our team took on a project where we tried to turn, let's say, an 8-step operation into one. And working with these systems that were designed in the 90s, a lot of them don't have APIs that you can access. So you have to build custom web interface components to mimic feature interactions as a human to actually move data across the system.
What year is this again?
This was...
Maybe you shouldn't.
Yeah, maybe I shouldn't give
okay.
the exact year, but very recent.
Very recent.
Which is completely unacceptable in my opinion, irresponsible. Like, we cannot be operating this way. If we want to stay ahead of our competitors, this is something that needs to be solved. And I don't think relying on a software that was built in the 90s is going to cut it for us right now.
I hear you. And I won't name names or timelines either, but I've been through some gruesome implementations. I'm talking, 2-3 years, multiple go live attempts. It's true. The horror stories are true. What you read online is true. So, let's start wrapping this up. I have one last question for you. Why this space? I mean, like, why are you spending your time? You're a smart guy, I would argue. You could be working on anything you want, and you're spending your time on, these systems that power manufacturers or turbocharge manufacturers. Why is that so important to you?
This is a really polarizing take.
Uh-oh.
Well, politically, I guess. But early in my career, when I got to Tesla, I never thought I was going to leave Tesla. their mission to transition the world to sustainable energy was something that I deeply aligned with. The only way I thought I was going to leave that company was if I went to SpaceX, and I was to go on a mission to make us multiplanetary, right? It wasn't until Shield reached out to me and told us how grave the situation was in terms of our sovereignty and our future. If we did not get ahead of the race to deter China from entering Taiwan and critically cripple our infrastructure. At that point, it was like, okay, I really want to get to space, but we can't get to space if we don't have the infrastructure to help us get there, right? And it really was an alligator closest to the boat model for me, right? You can float down the river, right, and have a really great end destination. But if you don't take care of this alligator right in front of you, you're never going to get there. So that was what really got me to jump ship and go to Shield and really hammer down on that mission with them. And I eventually went to Mach because I saw the opportunity to really supercharge our capacity as a country.
Have you ever had alligator before?
I have, actually.
Me too, yeah. Fried, tastes like chicken.
Yeah. It's pretty good.
Awesome. Well, Christian, thank you so much. It's been awesome getting to know you and working alongside you, and I appreciate you flying up to San Francisco and having this chat with us. Everyone else in the crowd, thank you so much for attending. I hope you enjoyed the talk. I hope it inspired you to maybe work on something a little more important for all of us. Enjoy food, drinks, mingle. Come chat with me and Christian if you want. We're going to have some brewskis, and have a good night.
Yeah, thanks for having me, Alex.
Of course.